I'm Christen Longoria, and I'm here to give you a brief intro into the Bridge Maintenance and Improvement Program and how it can help us extend the life of our bridges. Following my brief overview, Gabriel Villarreal is going to expand on two projects that we've selected in the San Antonio district. Did you know that almost half of the Texas on-system bridges are 50 years or older? The Bridge Maintenance and Improvement Program is a planned, cost-effective treatment for preservation. The number of structurally deficient bridges has been reduced by replacement through the Highway Bridge Program. So the funding focus has shifted from replacing bridges to preservation and maintenance. The goal of this program is to extend the life of the structures by 25 years or more and reduce the overall life cycle costs. We can accomplish this by focusing on large-scale preservation projects to improve the physical condition of the on-system bridges. And the best part is there's $45 million in federal funds dedicated to this program. So, how do you qualify? At least one of the primary elements of the bridge has to be rated at least a 5, which is fair, or a 6, which is good. A bridge is not eligible if it's already programmed or scheduled for replacement, or if it's eligible for the Highway Bridge Program. And finally, the improvements must raise the elements up to a 7, because remember, the goal is to get us another 25 years of service life. So now that you've established that your bridge is eligible, what work categories are covered? Well, bridge ratings are covered if the bridge has damage from overheight impacts that resulted in a lower condition score. Deck rehabilitations, that's a popular one. Retrofits of 2-column vents and crash wall installations. Steel protective coatings are covered. Relief joints in concrete paving and or approach slab work up to 40 feet. Approach work including guard fence, safety end treatments, and transitions, but only when it's associated with other improvements that have already been approved, and there's a 100-foot limit on those. Post-tension repairs are also covered. And repairs are covered on the substructure as well. The desire is to cover all project-related expenses and get those ratings up. So, what's excluded? It's also important to know what is not covered under this program. It does not cover bridge widenings with new substructures. It doesn't cover total bridge replacement. It doesn't cover when you're just doing bridge rail upgrades or when you want to remove debris. The intent of the program is not to cover emergency repairs or to address your critical findings. Remember, the purpose is maintenance and preservation, so keep that in mind when you're selecting your projects. So what's the next step? Well, Bridge Division provides a list of eligible bridges, and the districts have the opportunity to review it and recommend any additions. Then we as the districts prioritize the projects and send it back to Bridge Division with the scope of work and a cost estimate. There's a committee that's designated to review and prioritize this master list from all the districts and all the projects statewide. And they're responsible for funding the project and keeping everything within the allotted budget. And the committee consists of people from Bridge Division, as well as Maintenance Division, and there's also district representation there as well. And they're really your best resource if you have questions about the program or whether the work you want to do is covered or not. And I recommend you talk to Graham Bettis if you have any questions. So when does all this happen? You can find a very detailed schedule in the Bridge Project Development Manual, and I really recommend you go look at it, because it outlines all the key dates and the action items. I think the first important milestone for the districts is the program call, which occurs in January and February. So next up is the good stuff. The picture that you see on the left is a truss bridge on IH10 frontage road at Sibyl Creek that's getting several maintenance upgrades and improvements. And these are the two San Antonio district recipients of these funds. And the picture on the right is IH10 also on Amanda Street, which is a bridge where the abutments are rotating from pressure from the expansive soils that we have in this area. And this one's a very interesting little project that we're starting construction on soon. So with that, I'm gonna hand it over to Gabe, and he's gonna give you more information on these two projects.
Awesome. Thank you, Christen. Yes, I'm very excited to go through these two projects that were selected for the San Antonio district. First off is the IH10 Sibyl. It's located on the east part of San Antonio, right at the boundary between Comal and Guadalupe and Bexar County. The existing structure actually was constructed in 1932, so it's about 84 years old, so it exceeds the 50-year part of this program. But it's been there. I've driven it across a few times. Basically, it's a main span pony truss structure. It's got 5 adjacent spans that are steel beamed deck standard structures. So, but the focus was mainly the steel structure that's been there quite some time and starting to experience some rusting. As you can see, some of the up to 7/16 of the top deck rust plate connection on one of the members through the inspection has shown that it's lost about 1/8 of a section loss over that cover plate due to rust. So the majority of this project is going to be to reestablish the coating of this steel members for this structure. Another place, there's some broken welds showing at some of the locations due to either impact or separation, expansion, contraction. So we need to get that fixed up. We also have some deformation on some of the steel members, starting to get out of line, out of plumb. That one's pretty good. Also been impacted, that's right above the rail, the traffic rail that's attached to the structure. It's been impacted and there's some major deformation there. So what are we going to do to this project? Basically, we're going to go in there. The majority of this project is to clean and paint all the steel members as indicated earlier. We're going to heat, strengthen, and or replace deformed members. Additionally, the main span is going to have a new deck, so we will replace the deck. Through inspections, it showed that there's major deterioration and cracking on the deck, so we will replace the deck for the main span as well. The concurrent 5 spans are going to actually get a concrete overlay. We're going to remove the existing asphalt, put in a concrete overlay. Those decks will remain, and only the main span is going to get replaced. Ultimately, to hopefully look like that. One of the challenges we had on this particular project was environmental. So testing came back indicating that there was lead in the paint. So for the safety of the workers as well as the environmental being over Sibyl Creek, we implemented in our plans to have a full encapsulation of the structure while the work's being performed. Requirements on the contractor to have certified individuals that know how to handle lead-based paint, and then not allowing any debris to fall into the Sibyl Creek. So this is a sample project that has been done in the past, and we're implementing it in this project, but it's still soon to be constructed. So, second project, this is the interesting one that Christen was mentioning. This one's IH10 Amanda. It's actually still east of San Antonio, but further in town within the 410 loop. There's 2 bridges for this particular location. Eastbound, westbound main lanes of IH10. We've broken it up into 4 abutment quadrants just to kind of talk about some of the specifics and how it was managed. But in essence, it's 2 structures on this project, and we've focused on identifying 4 abutments within this project. Some of the issues of the rotation that Christen was mentioning due to high expansive soils have caused spalling of concrete, exposed rebar at the wing walls and the abutment, and it's starting to rust away. Talked to some of the maintenance folks, and they've gone out there and hammered on some of that spoiled concrete, and it doesn't even have a density to it. It's just falling apart. So some major issues at the abutments. In our site inspections, we also noticed that there was a slope failure in the vicinity. There's just a lot of movement. Soils are moving. Failures, not a good condition. In addition to the high PI soils, it's causing the riprap to swell, crack. Water's getting in there. It's getting worse. It's propagating the problem. We got to get that sealed up. So, in addition to this, we were going out there. One day we did a site visit. A couple weeks later, we did another one, and there was riprap. And so there's actually work being done. So we coordinated with the area office to develop, get our game plan in order to identify what they were going to construct and how we can solve the challenge of projects going on at the same time as us going in. So we worked with the area office to mitigate some of those improvements as this project was going to come in and have to get into that area to improve this project. So that was interesting too. So this is actually an animation. One of the challenges we had on this project was constructability. How do you go in there and retrofit a cap, support the abutments while trying to maintain traffic on top? And so this is an animation of how we would kind of go through that process, and I'm trying to find my play button. There we go. So you can see here, this is only showing one abutment. We did it for the entire bridge. We basically put barrier to provide a work zone for the contractor to come in, remove the existing approach slab, place some sheet piling to support the abutment so that we can get underneath the structure to retrofit the cap, replace the existing rocker bearings with a elastomeric bearing pedestal. The jacks we didn't actually lift the profile higher because there's traffic on top, but we did it so you can see the simulation. We basically just supported it, removed the existing bearings, replaced with the new ones. And this is the retrofit of the cap. There was invisible forms there. So with some new reinforcement and some new concrete to encapsulate, we placed wing walls and other work in the same phase. Another issue we had was that these slopes were 2-to-1, unstable. A lot of the issues with the riprap, so we developed a retaining wall to flatten these slopes from a 2-to-1 to a 3-to-1. That stabilized the abutment, replaced the caps, new concrete to prevent water from getting into the poor soils that were existing there. And again, we did it for all 4 quadrants, so we just showed the animation through one of the quadrants. So, a couple lessons learned on this project. You got to think outside the box. The constructability was a big challenge on this, trying to maintain traffic, trying to get the contractor in there. We utilized some unique techniques in order to get this project done. You got to stretch the dollars. There's only limited funds on the project, as Christen was discussing. You got to get as much improvements as you can with the amount of money you have. So we found innovative ways to try and extend the dollars utilized for this project. There were some things that were a little more expensive, but we were able to compensate with other means of cost reductions tools. So the challenge on these projects actually is estimating your costs, because average low bid price on the TechSouth's website doesn't really help in these types of projects because they're not long linear roadway projects that are very common. So we had to utilize RS means. We work with contractors, unique sheet piling. We gave them preliminary design plan, said, hey, how much would this take? How long would it take? What's your cost? So we kind of work with our contractors, use our relationships to get average cost for unique items. We also utilize other BMP projects that were let in the past, look at some of the bid prices for some of that stuff. Smaller quantities always drive the cost up. So we were actually able to let this project, and it was within 4.3% of the engineer's estimate. So with those techniques, it's the best way to utilize and get good prices for the projects. The key to this success is communication. We had about 4 months to design this. We had coordination with the San Antonio district, Bridge Division, Area Office, USGS. They had a gauge data on one of the projects. Communication is key. You gotta talk, you gotta meet. We had weekly meetings. Coordination with the existing project that was there, salvaged some money. We removed some cost out of their project because we were gonna come in and rip it out and put it back in. So that's other ways that you can communicate and save some money. But I just wanna give shout out to San Antonio District, great to work with. Bridge Division, they worked on the Sibyl design plans, specifically Kevin Pruski, Stephen Austin, and Jeff Tompkins and their group, as well as HDR, our structural staff there, led by John Holt, worked on this project, and together we were able to, I feel like, have a real successful project. So with that, is there any questions? Yes, sir.
You said cost estimate was 4.3% of the engineer's estimate.
Mm-hmm.
What was the engineer's estimate then?
Sure. So the question was, the engineer's estimate was 4.3, or the bid was 4.3 less than the engineer's estimate, and our engineer's estimate was approximately $4.9 million. And so I think it was some 4.6, but that was for the Amanda project only. They weren't combined. There were two different plan sets.
The other one hasn't let yet.
Right. So the I10 Sibyl is going to let in January 2017. It's in processing right now. Yes, sir.
When you decided to redo the header on the bridge, the idea of widening that bridge and using up the other spans in the future, that was eliminated, right?
Well, that partially part of the funding does not allow for widening of the project, of the existing structures.
Widening underneath.
Right.
Seemed like redoing the header, you
Yeah.
might have an opportunity to add more lanes if that was needed.
And it's,
Now with the header redone and the retaining wall, that sort of suppresses that.
yes, you're right, and we did consider that, but Amanda Street is a local street with very, very small traffic volumes.
Yeah.
There's no anything planned in that area now, so we did consider that as well.
So this area also didn't have the frontage roads, and it is a city street, as she indicated, in coordination with the San Antonio, City of San Antonio didn't have any improvements on their master plan for that, so.